Hey guys, in this lesson we will talk about unit circle and its applications. Now the purpose of unit circle is to help determine the trigonometric ratios of the angles that have relationship to the angles of special triangle without the use of calculator. As we noticed in the previous lesson, that special triangles only contain acute angles. That was, we could find out the trig ratios for 30 degree, 45 degree, 60 degree and 90 degree. Now what are we going to do if we have angles that are greater than 90 degree and we're not supposed to use a calculator for the calculations? Then we use what is called unit circle. For that we need to first understand what is a unit circle. Unit circle name comes from a circle that has a radius of 1 unit. Now what we're going to do is we will divide this unit circle into 4 quadrants and we would use the coordinate grid to do so. So this is a positive x-axis, this is a positive y-axis, this is a negative x-axis and this is a negative y-axis. We know from the lower grades that in order to form an angle we need 2 arms, or in mathematical language these are called 2 rays. So whenever 2 rays join at a point, they form an angle. In simple terms, let's call these rays as arms, because trigonometry is all about angles and side lengths. So we would consider how the angles can be formed on the unit circle. The 2 arms that will form angle on this unit circle has specific names. One is called the principal arm and the other is called the terminal arm. Principal arm is the arm that would always stay at positive x-axis, whereas the terminal arm is the arm that is going to move around on the unit circle to increase the size of the angle. These 4 quadrants have specific numbers, so this is called quadrant number 1, this is quadrant number 2, this is quadrant number 3, and this is quadrant number 4. If the terminal arm lies on top of the principal arm, the angle that the terminal and the principal arm will make is called 0 degree angle. If the terminal arm is going to move away from the principal arm, it will increase the size of the angle. Only angles that we worry about is 0 degree, 30 degree, 45 degrees, 60 and 90 degrees. All these 5 angles would lie in the first quadrant. Angles could be any real numbers, but we just have to worry about these angles because these are the angles that can give us the ratios from the special triangles. So this angle formed between the terminal arm and the principal arm is called 30 degree angle. When the terminal arm moves further up, the angle it forms is called 45 degree angle, and when it further spreads out, angle it forms is 60 degree angle. And finally, when the terminal arm lies on top of y-axis, that is positive y-axis, the angle that it would form is 90 degree angle. This means if we are talking about angles from 0 degree to 90 degree, we are in the first quadrant of the unit circle. Now we need to know 2 very important definitions of angles for this particular unit circle or for this particular unit, and that is called principal angle and related acute angle. Related acute angle can be written as RAA. Principal angle can be written as PA. General denotion of principal angle is theta and related acute angle is denoted as beta. Simple definition of principal angle is the angle between principal arm and terminal arm. Related acute angle is the angle between the terminal arm and the nearest x-axis. Let's understand this concept using the following circles. Let's say in the first circle we are talking about the first quadrant angles. We know this is our principal arm and these are the axes: positive x-axis, positive y-axis, negative x-axis and negative y-axis, and this is our terminal arm. Let's say we're talking about angle 30 degrees. So we know principal angle is the angle between the principal arm and the terminal arm. In this case, the principal angle is 30. That means principal angle, which is theta, is equal to 30 in this case. Now let's talk about related acute angle. We know related acute angle is the angle between the terminal arm and the nearest x-axis. For quadrant 1, this is quadrant 1, we notice that the nearest x-axis for any angle is the positive x-axis. So the angle between the terminal arm and the nearest x-axis is also 30 degrees. Therefore, we can conclude that in the first quadrant, principal angle and the related acute angle are both equal. Let's move on to the second quadrant. Second quadrant lies from 90 degree to 180 degrees. Our principal arm always lies on the positive x-axis. So this is the principal arm. This is positive x-axis, positive y-axis, negative x-axis and negative y-axis. And let's say the terminal arm lies in the second quadrant. We know principal angle is theta, and it's the angle that lies in between the terminal arm and the principal arm. So this angle is called theta. Be it whatever number, but the angle that lies between the terminal arm and the principal arm is called principal angle. So that is why it's represented as theta. Now related acute angle is the angle between the terminal arm, which is this pink arm, and the nearest x-axis. Because we're in the second quadrant, the nearest x-axis is this negative x-axis. So this angle is called beta. And if we want to find out the relationship between theta and beta in the second quadrant, we see this entire angle would be equal to 180 degrees. Therefore, theta will be equal to 180 minus beta, or beta will be equal to 180 minus theta. This is the relationship for second quadrant. All of these relationships are very important for doing calculations, and these have to be memorized. Next, we talk about the third quadrant. Third quadrant is this one that lies from 180 degrees to 270 degrees. Principal arm is always positive x-axis. This is positive x, positive y, negative x, negative y. Because we're in the third quadrant, so terminal arm lies in the third quadrant. We know principal angle is the angle between the principal arm and the terminal arm. So this is the principal angle. And related acute angle is the angle between the terminal arm and the nearest x-axis. So this is going to be the related acute angle in this case. Therefore, for the third quadrant, conclusion is, because we know this part is 180 degrees. So to 180 degrees, when we add beta, we will be able to get theta. So we would write down theta is equal to 180 degrees plus beta. So this part plus beta will give us theta. And if we want to find out beta value, all we have to do is just isolate beta. So 180 degree moves on the other side becomes theta minus 180 degrees. Let's talk about the fourth quadrant now. This is the fourth quadrant. Fourth quadrant lies between 270 and 360 degrees. Principal arm, positive x-axis. So this is positive x, positive y, negative x, negative y. As we are in the fourth quadrant, so the terminal arm lies in the fourth quadrant. Angle between the principal arm and the terminal arm. Always remember, the angle has to be formed in counterclockwise direction. So we have to go in this direction. We cannot form the angle like this. It has to go in this direction. And this angle is called the principal angle. So direction matters everywhere. You're going from principal arm to terminal arm in counterclockwise direction. So principal angle is equal to theta. Now if you want to find out what is the beta, so we know beta is equal to the angle that is formed between the terminal arm and the nearest x-axis. For beta, we do not have to worry about the direction. So this is our nearest x-axis. Hence this is beta. Therefore related acute angle beta is this one. Now for fourth quadrant, the relationship is, because this covers up the entire circle, you know the entire circle is 360 degrees. So theta will be equal to 360 degrees minus beta, and beta will be equal to 360 degrees minus theta. Now why are these relationships important? Is because when we go back to our original unit circle and we see that our terminal arm in the first quadrant starts from 0 degrees, then move to 30 degrees, then move to 45 degrees, then move to 60 degrees, and then move to 90 degrees, is going to give us a trigonometric ratio. So if it is 30 degrees, and if we make this triangle outside the unit circle, it would look like this. So this is how we complete the triangle. This is going to be called the radius of the circle, because it's the length from the center of the circle to the periphery of the circle. This is the y-axis and this is the x value. So if we want to write down the trigonometric ratio for this, we can write down sine 30, as this forms a right angle triangle, and we already know from special triangles that sine 30 value is equal to 1 over 2, because sine 30 is opposite over hypotenuse. In this triangle, if we want to write down sine 30 in terms of x, y, and r, it is going to be equal to y over r because y is opposite and r is hypotenuse. And we also know this is a unit circle. So radius of the circle is 1. Therefore, we can say y is equal to 1 multiplied by sine 30, which is equal to sine 30. And the value of sine 30 from special triangles we know is half. So from here we can conclude that the point that is formed by the terminal arm on this circle, if it has coordinates x and y, then the y value of the coordinate is nothing but sine 30. And that's what we can see here. Similarly, if you work with cos value, so cos 30 is equal to adjacent, which is x over r. Because this is a unit circle, r is 1, we can conclude that cos 30 is equal to x. So this is going to be cos 30. Therefore, the coordinates of this point would be cos 30 comma sine 30. Similarly, the coordinates for this point could be cos 45 comma sine 45. Coordinates for this point is cos 60 comma sine 60. And coordinates for this point is cos 90 comma sine 90. In other words, we can say that the coordinates of this point is going to be, because cos 30 is root 3 over 2 and sine 30 is 1 over 2, cos 45 is 1 over root 2 and sine 45 is 1 over root 2, cos 60 is 1 over 2, sine 60 is root 3 over 2. And to figure out the value for 0 degrees and 90 degrees is very easy because we know this is the x value and this is the y value. So here the x coordinate is this entire radius of the circle, that is 1, and y coordinate value is going to be 0. Whereas when we move on to 90-degree angle, it becomes 0 and 1 because this is the x value and this is the y value. And y value here is going to represent the radius of the circle, which is equal to 1. In this case, x value represents the radius of the circle, which is equal to 1. So the angles that we're getting these values for is 30 degrees, next is 45 degrees, next is 60 degrees, and then the next is 90 degrees. Now we already know these values from special triangles. So what is the role of unit circle in this whole case? Is that if we have this terminal arm moving on to the next quadrant, so when the terminal arm moves on to the second quadrant, the only angles that we have to consider should be the ones that have the same related acute angle as 30, 45, 60, and 90. We know that in the second quadrant, related acute angle is going to be between the negative x-axis and the terminal arm. Therefore, the related acute angle that we have to consider here is 30 degrees, here 45 degrees, and here 60 degrees. So when it comes to the principal angle, if this way is 60 degrees, this way is going to be 180 minus 60, which is 120 degrees. Similarly, if this way is 45, this would be 180 minus 45, that is 135 degrees. Similarly, if this way is 30, this way is going to be 180 minus 30, which is 150 degrees. And when the terminal arm is going to touch the circle in the second quadrant, it will again hit the circle at certain points that would have coordinates. The coordinate values that are in the first quadrant and the coordinate values that are in the second quadrant, in fact, the coordinate values that would come in the third and the fourth quadrant, they all are supposed to be same because they have the same related acute angle. And that is same as the angles in the first quadrant, 30, 45, 60, and 90. So the value that the 30-degree angle has here, that is root 3 by 2 and 1 by 2, the same coordinate value it will have here as well, root 3 by 2, 1 by 2. The same coordinate value it will have here, 1 by root 2, 1 by root 2. And the coordinate value that it had here for 60 degrees, it has the same coordinate value here, that is 1 by 2, root 3 by 2, because it is 60 degrees when it comes to related acute angle. Therefore, we can say here cos 30 is root 3 by 2 and it's equal to cos 150. That is also equal to root 3 by 2. And what is the reason behind it? Because these values are nothing but x and y values. In the first quadrant, we have positive x and positive y, because we are lying in between a positive x-axis and a positive y-axis. Whereas in the second quadrant, we lie between a negative x and a positive y-axis. So always remember that in the second quadrant, the values are same, but the signs are not same. Therefore, the cosine values are negative. So if we are asked to find out the trigonometric ratios for any angle that lie between 90 degree and 180 degree, we know that angle lies in the second quadrant and the angle ratio is going to be negative for cosine, positive for sine. Similarly, if we talk about the third quadrant, so this is our third quadrant, the only angles that we will be considering is 30, 45 and 60. So it is going to be related acute angle 30, 45 and 60, whereas now the principal angles would be 180 plus 30, which is 210. So the ratio for 210 and 30 will be again same, and that is root 3 by 2, 1 by 2. This is 1 by root 2, 1 by root 2. And this is 1 by 2 root 3 by 2. However, in the third quadrant, because we are lying in between negative x and the negative y-axis quadrant, so both x and y values are going to be negative. Therefore, if we know cosine 30 is a positive root 3 by 2, because 30 lies in the first quadrant, then cosine 150 is going to be also root 3 by 2, but this is going to be negative because cosine values come from x-axis, and x-axis in the second quadrant is negative. Similarly, cosine 210 that comes from the related acute angle 30 degrees is also going to be equal to root 3 by 2 with a negative sign, because third quadrant also has x negative. And in the same way, when we reach the fourth quadrant, we know this is 30, this is 45, and this is 60. The ratios stay the same, root 3 by 2, 1 by 2. For x and y, 1 by root 2, 1 by root 2, and this is 1 by 2 root 3 by 2. However, in the fourth quadrant, your y value is negative, so the sine values are going to turn negative. The corresponding theta value in the fourth quadrant is going to be 360 minus 30, which is 330. That is also root 3 by 2 with a positive sign. So we see every ratio is repeated 4 times, 2 times negative and 2 times positive. And this is the case for all the angles and for all the ratios in any quadrant.